Hey, Sophia. I'm doing the video on number three. You asked for A, C, and D, but I figure I may as well just do the whole bloody thing. So I'm going to do all four of them. First question: what is f of negative six, and what is f of five? If you know f of two is seven. So what's going to be important here is that we know the area under this curve here in green of that graph is 4, because 1/2 base times height. This height is 2, that's 4. So the area of that triangle is 4. We're going to need that for the fundamental theorem, right? And then this is a half of a circle with a radius 2. So the area of a circle is pi r squared. So 2 squared is 4, half of 4 is 2, so that area is 2 pi, but I made it in red because it's negative. Um, and then this is 3 and that height is 2. Again, it's 1/2 base times height. So if that height is 2, the base is 3. 1/2, 2 times 3 is 3. Now, why is that important? Because if remember, I think you asked me this question on a previous test. If I give you f of some value, in this case, f of negative 2 is 7, and I ask you for any other function value, like in this case negative 6, or we're going to want to also figure out 5. We're going to want to figure out f of negative 6 and f of 5. That's the question. You want to, when you see this, you want to think fundamental theorem. The antiderivative from 6 to negative 2, because 6 to negative 2 of the derivative is f of negative 2 minus f of 6. And then for 5, I'm running out a little bit of room here. I'm going to do it down here. Negative 2 to 5 of the antiderivative of df is going to be f of 5 minus f of negative 2. The key is that we know the negative 2. And what we can do is we can figure out the integral here. If I go from negative 6 to 2, and I do that integral, that's 4. So what I know is this is 4. I know that's 7. So I can actually calculate the f of 6 by moving the, oh yeah, we're good. So I move that over negative side. I sorry, I had a brain stall. F of negative 6. So it's supposed to be negative 6. My writing is getting a little sloppy because I'm trying to sit down while writing. There's double negative there, so I can end up getting rid of that negative, and I get 3 for that answer. And then the next one, from negative 2 to 5, negative 2. So if I go from negative 2 all the way to 5, I'm going to get the 3 minus the 2 pi for the integral. If I integrate, start integral over here, I get negative 2, and then I get 3. So I know that integral is 3 minus 2 pi, f of 5. And again, I know f of 2 is 7. I move the 7 over to the other side, I get 10 minus 2 pi. So 10 minus 2 pi. And so these are the answers to the A question. Now you didn't ask me for the B question, but I figured I may as well put it in here and make one long video of the whole dang thing. The B question, and hopefully you didn't ask it because you know how to do it, is intervals where f is increasing. F is increasing when its derivative is positive, right? That's like the thing about calculus, right? It's positive until I get to negative 2. And it's negative until 2. This is the derivative. Because this is the, this is the graph of the derivative again. I just do it twice, one with the areas underneath it. And then 2, and then it's back to being positive. So you're going to say, what, negative 6 to negative 2, and then 2 to to 5. And I'm not going to spend a whole lot of time on that because A, it's not that hard of a question, and B, I think you didn't ask for that one in particular. And then the C question, A, B, C. How do you find absolute max and min? You need the critical numbers and the endpoints, and it turns out that's really nice because they had us do the endpoints, didn't they? This often happens in this type of question. So let's say, wait a minute, C question. How do you justify a max or a min? Remember the way I taught you to justify a max and a min in like the brute force method, like this one always works, is you check the endpoints and the critical numbers. Now, what are the critical numbers? When the derivative changes from positive to negative or negative to positive. So the derivative is going to be 0 here at 2, changes positive to negative, and negative 2, and then positive 2. Now, we know f of negative 2, that's 7. And here's the cool part. We calculated f of negative 6, and we calculated f of 5. The only one we didn't calculate was 2. So I'm going to have to do the calculation, negative 2 to 2 of the derivative. So I'm going to do the same thing I did earlier, but I'm only have to do it at this one point because the other 3 I already did. Well, 2 I did and 1 they give you. So that's going to be f of 2 minus f of negative 2 using fundamental theorem. And the integral from negative 2 to 2 is negative 2 pi. And this is going to be f of 2 minus 7. So when you bring the 7 back over, 7 minus 2 pi. And so you get 7 minus 2 pi. Now, which one, and now I actually forgot. Hold on, I gotta read the question. I forgot what they're asking for here. I forgot whether they want the absolute max or the absolute min or both. I did not write that down here. Minimum. Okay, so 3, if I take 10 minus 6.28, remember I don't have a calculator, so I'm going to have to kind of do this in my head. That's going to be like, I don't know, 3 something. 3 something. 3 something, right? This is going to be like almost 0, right? This is going to be 6.28. This is going to be almost 0. 7 minus 6.28 is what? Actually, looking at my head, right? 28, so that's going to be what? 7.72. So 0.72. So 0.72 is going to be the lowest. So the absolute min is this. Now, do they want the x value or do they want the y value? Find the absolute min. So the answer to C is the absolute min is 7 minus 2 pi. At 2. So the absolute min is going to be at 2. Now, I will say this, you don't actually have to check the negative 2 because it's a relative max, so you only have to really check the relative min. Now, of course, you always have to check the endpoints though, but we did, the AP exam would not be upset with you if you didn't check that number because it's a relative max, so it's a continuous function, so it's not going to be an absolute min if it's a relative max. But I would just check all of them. That's just my opinion. And then the last question was, what are the second derivatives? Now, the second derivatives at negative 5 is right here and here at 3. So I'm running out of room here, so let me just put the D over here. The second derivative at negative 5 and the second derivative at 3. What we want, the second derivative would be the derivative of the derivative, so I want the slope of the line there. Oh crap, I want the slope of the line here. Well, okay, it's pointy, so that's bad, but you can't say that, right? You can't say, oh, it's pointy, so it's bad, right? So, and then over here, oh, but that's what we can figure out, right? Over 4 down 2, you can say that slope is negative 1/2. So you can figure out this is negative 1/2. Just do the slope of that line. Here, it'd be nice if we could say it's pointy, and therefore there's no derivative. But what you want to do is say the limit Well, you can say it does not exist. Let's do that. Oh, that looks really ugly. Hold on. Does not exist. But you probably want to say the limit as x approaches 3 from the left, limit as x approaches 3 from the right of the derivative here. What you want to basically say is the derivative from the left is positive, is bigger than 0, and the derivative from the right is less than 0. Now you can actually calculate that slope is 1, that slope is 2, and that slope is -1, and that would be fine too. It doesn't exist because the derivative from the left doesn't equal the derivative from the right. And the way we say derivative from the left and the derivative from the right is by writing a limit of the derivative from the left and a limit of the derivative from the right. So hopefully that answers your question. I'll get to your other question tomorrow, if that's okay with you, the 1D. I'll talk to you guys tomorrow then on that. Okay, bye-bye.